Welcome to this presentation about artificial intelligence in European small and medium enterprises, how innovation promotes digital transformation and transition. I'm going to present here the four results on this research on AI and SMEs that is being carried out by Universitat Oberta de Catalunya professor Joan Torrent Sallents and Martí Bostubella, myself. First, I would like to take a look at SMEs in Europe. They are the 99% of business in the EU. They represent the 64% of employment, and they constitute the 52% of European GDP. So, in this research, we ask ourselves, what are the drivers of digital transformation? What are the innovation mechanisms that are used in SMEs? And finally, we see that AI adoption is correlated with bigger firms, slightly higher productivity, and more innovation. So what's the role of artificial intelligence in all of this? I don't want to talk much about the previous literature on AI, as I'm sure the audience is already well versed on the topic. Basically, we use the TOEI framework by Tornatsky and Fletcher and the TAM adoption model by Davis that can be merged into the TOEI TAM framework widely used in the business innovation discipline. It can be divided in three categories. First, we have the technological context. Literature has proven that more technology increases the adoption of other digital technologies such as big data and cloud computing. It is expected that a similar link can be found with AI. Second, we have the organizational context. Scholars argue that the digital transformation is going to need some kind of organizational changes in firms. Collaborative networks and platform technology is expected to help SMEs to introduce these new digital tools. And finally, we have the environmental context. Business connection to collaborate between partners or better business infrastructure has shown to increase the adoption of new technologies. But this digital wave goes beyond web pages and computers. This could be a new technological revolution. We argue that there are significant digital complementaries between these novel technologies. We've categorized two different groups. First, AI-based algorithm and software, AIAS. This is machine learning and artificial intelligence algorithm combined with big data tools and high-demanding computer systems that translates to cloud computing. Second, AI-based hardware and infrastructure, AIHI, include robots and machinery, all devices and high-speed infrastructure. It is expected to be considerable complementarities inside these technology groups. Nevertheless, there is an important complementary effect across technology groups. Smart devices complement big data procedures, and high-speed infrastructure is beneficial for an intensive use of software. That's why our hypotheses are the following. First hypothesis. Digitalized enterprises are more likely to implement new advanced technologies. Second one, more innovative enterprises are more likely to implement new advanced technologies. Third, enterprises with more external resources available are more likely to implement new advanced technologies. The last one, there are some differentiated trends between AIAS and AIHI. The data we employed in our research comes from the Flash Eurobarometer 486 from 2020. It contains more than 13,000 enterprises across 33 European countries. We use two different dependent variables. The first one, soft tech, that refers to AIAS. It values 1 if the firm uses some of the following technologies: AI/ML, cloud technology, or big data. Whereas the second one, hard tech, refers to AI/HI. It values 1 if the firm uses some of the following technologies: robotics, smart devices, or high-speed infrastructure. We employed a logistic regression model with variables that cover the whole TOEI framework. We include controls for firm size, economic sector, and country fixed effects. Here we can see the first analysis of our research. Here there is the 10% of respondents of each economic sector that reported they use any of the technologies included in the soft tech or hard tech variables respectively. Values are rather similar, but I would like to highlight electricity, gas and steam, which shows a significantly higher hard tech percentage compared to soft tech. Information and communications is one of the highest value in both cases, but is especially higher in soft tech. Something similar happened also with professional and scientific activities, education, or also finances. This confirms our hypothesis about a differentiated pattern depending on the economic sector. Here we can see the two logic models about the technological context in European SMEs. The first one employs soft tech as the dependent variables, whereas the second one uses hard tech. Both include the same covariates and controls. Most variables studied here, as you can see, are significant. It should be noted that the indicator data access problems is significantly negative for hard tech, but it's not significant for firms that adopt soft technologies, which tend to be more data intensive. Same for digital transformation issues and market prediction difficulties. They are significantly positive for hard tech, but not significant for soft tech. Digital security concern is also significantly positive for soft tech, but not significant for hard tech. Whereas missing ICT equipment is positive for soft tech and negative for hard tech. This means that soft tech users do not find enough ICT equipment, but hard tech users do. If we look at the organizational model, most variables here are also significant. The main differences are found in the ownership, where soft tech enterprises report significant negative estimators for one-person owner and family business. But these variables are not significant in hard tech adoption. More than one owner and public entity participation are significant and positive for hard tech implementation, but not significant for soft tech. Business angel participation is also positive and significant for soft tech introduction, but not significant for hard tech. Finally, we found a strong correlation between all measures of innovation and both soft tech and hard tech adoption. It should be noted that the highest estimators are found in different kinds of innovation depending on the technology implementation. Environmental context shows a similar scenario on both studied cases. The most significant difference is found in business condition variable, which is not significant for soft tech but significantly positive for hard tech. Collaboration is found not significant, and although legal and administrative environment is not significant for neither dependent variable at first, indicators that measure issues when innovators show legal problems and administrative obstacles. The initial ideas that so far we can conclude from our work are the following. First, our results support that more technology increases digital transformation and the introduction of new technologies, both for AI/AS and AI/HI. Not surprisingly, innovative firms are usually the first to introduce new and more advanced technologies. There are, however, some differences on the kind of technology implemented depending on the innovation style. A better business environment improves the implementation of new digital technologies, although some significant barriers are detected in innovation collaboration and legal issues. The most important difference between AI AS and AI HI are found in economic sectors they are implemented in, or when studying the ownership and capital participation of SMEs. Nevertheless, complementarities are important and it is expected that to continue to grow across different sectors and digital technologies. Here are the references. Thank you.